projects. In this video, we are going to explain about a project entitled as Machine Learning in Hospitality, Interpretable Forecasting of Booking Cancellations. So, before getting into the video, let me give you a brief explanation about the project. Hotel booking cancellations are a serious challenge for the hospitality industry. They can distort demand forecasts and causes revenue losses of up to 20%. To tackle this issue, our study develops a new machine learning framework that can accurately predict booking cancellations before they happen. We can use a technique called stacked generalization, which combines multiple machine learning models, including linear models, tree-based models, and deep learning networks, into one powerful meta model. This combination boosts prediction performance, achieving an impressive 96% of accuracy in forecasting cancellations. But prediction alone isn't enough. To make sure the results interpretable, we apply explainable artificial intelligence tools. This helps us understanding why cancellation happen, revealing important behavioral factors such as hotel location, room type, and customer segmentation. With these insights, hotel managers can take data-driven actions like adjusting prices, sending reminders, or targeting promotions to reduce cancellation. In short, our study combines high accuracy and clear explanation to provide a particular solution that helps the hospitality industry improve forecasting, revenue, and customer satisfaction. Coming to the existing system. The existing system uses traditional models like logistic regression, decision tree, and random forest to predict hotel booking cancellations based on past data. However, they have limited accuracy, can't capture complex customer behavior, and offer little explanations for their predictions, making them less useful for hotel managers to take effective action. Coming to the proposed system or the base paper work, the proposed system combines multiple machine learning models using stacked generalization and explainable AI to predict hotel booking cancellations with 96% of accuracy. It not only improves prediction performance but also explains key factors like location, room type, and customer segmentation, helping hotels make data-driven decisions to reduce cancellation and revenue losses. Coming to the dataset, this project uses hotel booking demand dataset from Kaggle, which includes detailed booking records with features like hotel, is cancelled, lead time, arrival date year, arrival date month, arrival date week number, arrival date day of month, stays in weekend nights, stays in week nights, adults, children, babies, meals, country, market segment, distribution channel, is repeated guest, previous cancellation, previous bookings not cancelled, reserved room type, assigned room type, booking changes, deposit type, agent, company, days in waiting list, customer type, address, required car parking spaces, total of special request, reservation status date. The target variable is cancel status, whether a booking was cancelled or not. This dataset is used to train and test the various predictive models evaluated using accuracy, precision, recall, and F1 score. Coming to the novelty or extension or improvement or enhancement. So as an extension, we have done label encoding and feature selection using RFE. Label encoding was applied to convert categorical data into numerical form, and RFE was used to select key predictive features. These steps enhanced model efficiency and achieved a peak accuracy of 98.7% with a voting classifier. And as an extension, we have used voting classifier ensemble implementation. A voting classifier combines decision tree and MLP models was developed to merge their strengths. This ensemble improved robustness, reduced bias, and outperformed the original stacking classifier. And we also integrated of Lime and SHAP for explainability. Lime and SHAP were integrated to interpret model predictions and highlight influential features. These tools improve transparency and user trust in the model's decision-making process. And Flask-based front-end with user authentication is also implemented. A Flask-based web interface with user authentication was created for secure, interactive predictions. It allows users to input data, view model output, and visualize results easily. Coming to the flow of the work. Firstly, we need to import the packages, which means load essential Python libraries for data processing, visualization, and machine learning. Then, exploring the data set. Understand the data set structures, features, and data quality. Then, data pre-processing. It cleans the data by handling missing values and duplicates. Label encoding. It converts the categorical variable into numerical form for model compatibility. Resampling the data. It balances the dataset using random undersampler to prevent model bias. Data visualization. It creates visual insights through graphs and charts. Data splitting. It divides the data into training and testing sets for evaluation. Building the classification models. It develops multiple models to predict the booking cancellation. Then, training the model. It trains each model to predict data to learn the predictive patterns. Followed by model comparison. It evaluates models using performance metrics to identify the best one. Comparison of graphs. It visualizes model performance across key metrics. Save the best model. It stores the top performing model for future predictions. Explainable AI visualization. Using Lime and Shap to interpret and explain model predictions. Coming to the front end. This project is developed using a Flask framework featuring user registration and login functionality, supported by an SQL database. After logging in, users can input feature values to the front-end interface. These inputs are pre-processed to match the model's requirements and then passed to a trained machine learning model for predictions. The predictive results are displayed on the front end, providing users with an interactive and user-friendly experience for making data-driven predictions. The algorithms used are logistic regression, SVM, support vector mission, decision tree, random forest, gradient boost, XGBoost, light GPM, MLP, multi-layer perceptron, stacking, and as an extension we have applied voting classifier. Coming to the requirements, we have hardware requirements and software requirements. Hardware requirements: operating systems Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements: application framework is Anaconda, primary language is Python, front-end framework is Flask, back-end Jupyter Notebook, database SQLite 3. Technologies which we use to build the front-end are HTML, CSS, JavaScript and Bootstrap 4. To execute this project, firstly, we need to open the code folder which contains the project source code file. So, in this, you have static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap. Template folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are the model files, which contain algorithm information which will be loaded into the project code during runtime. Notebook.ipynb. This is a Jupyter Notebook file which contains a combination of codes, graph, and outputs all in one place. It allows user to write and execute code in individual cells, making it a popular choice for data science. Signup.db file. This file is a database file used to store user information. Now, coming to the execution. Copy the path of the code folder from the address bar of the file explorer. Then, open Anaconda prompt. Use the command cd followed by a space, then space the path. This command is used to change the current direction of the code folder's path. Then click on enter. Compile the app.py file using the command python space app.py. This command will execute the Python script and perform a runtime check for a syntax errors or logical issues. After running the app file, the Flask framework will host the application locally at the default address. Copy the link provided by the framework and paste it in any web browser. I prefer Chrome. So, this is a web page of the project which is displayed in the browser. This is developed by using Flask framework. So, firstly, we need to click on sign up. New user sign up registration. So, firstly, we need to give the user details for registration process. Here, username, full name, mail ID, contact number, and password. Click on create an account. The account has been successfully created. So, to log in, we need to log in as a user. We need to give the username and the password. Click on sign in. Now, we have signed in successfully and redirected to the page. So, in this page, we have home button, about button, notebook button, and logout button. So, in the home button, we have try prediction and view data analysis. Firstly, we need to click on try prediction. Here, we need to check the booking risk. Firstly, I'm going to select the hotel type, like whether it is resort hotel or city hotel. Then market segmentation, repeated guest, deposit type, total of special request, children, distribution channel like corporate, previous cancellation, assigned room, required car parkings, and reservation status. Click on predict cancellation risk. So, for the given inputs, it is predicted as high cancellation risk. The model confidence is about 71.9%. The given inputs are pre-processed and given the output as high cancellation risk. And the model confidence is about 71.9%. The prediction is being cancelled. Analysis type is of ML prediction. Here we have the key insights like high cancellation probability detected, consider proactive guest engagement, review booking conditions and policies, monitor for early warning signs. And the recommendations are immediate actions like contact guest to confirm booking, offer flexible cancellation policies, and provide personalized service. Revenue protection, consider overbooking strategy, implement waiting list management, and monitor similar bookings. Okay, then click on new prediction. Here you have view data analysis. In this, you will find the graphical representations of the project, like the dataset overview, like 72.5% of data has been not cancelled and 27.5% of data has been cancelled. And we also have balanced booking cancellation overview and confusion matrix, accuracy of all the ML models, like the x-axis consists of the algorithms and y-axis consists of the accuracy. Prediction graph, the x-axis consists of algorithms and y-axis consists of precision. Recall, x-axis consists of algorithms and the y-axis consists of recall. In the same way, we have F1 score, ROC accuracy, specificity, sharp explainable AI feature importance. Then click on logout. Finally, the project efficiently applies machine learning techniques to forecast hotel booking cancellations with accuracy and interpretability. By integrating data pre-processing, model training, a user-friendly Flask-based interface, it provides valuable insights to help hospitality business reduce cancellation rates, improve resource management, and enhance overall operational efficiency. So this is all about your project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Project's YouTube channel and subscribe.